Hello, my name is Walter Unglaub, and this is Echolocation in Physics. Echolocation is the primary mechanism that is behind or responsible for sonar. And sonar is actually an acronym for sound navigation and ranging. And it involves a source, some sound source, so a transmitter, such as a speaker, that sends out an acoustic wave through some medium. Typically, sonar is used underwater, but it doesn't matter as long as there is some medium by which the sound waves can travel. And you'll have some target, like a submarine, or maybe some other topological feature, such as a rock or a mountain. And when the sound wave hits this target, it'll scatter, and part of it will reflect. And so you'll have a transmitter, but also a receiver at the source. And if you know the speed of the sound in the medium, which I'll denote as Vs, and you know the initial time and the final time from which the signal was sent and then received, then you can calculate the time difference between transmitting and receiving as simply the final time minus the initial time. Thus, you can determine the length and position of this target object away from where you are by just considering these two parameters. So, if we have some length L between this transmitter, the source, and the target, we understand then that the speed of sound is going to be given as 2 times that distance because of the fact that there's a round trip time, divided by that round trip time, delta t. Therefore, the distance is equal to the speed of sound in the medium times the round trip time divided by 2. And doing this automatically allows us to navigate in regions where we can't necessarily see all the objects around us, so we can determine the distance and location of these objects. And this is the primary principle and mechanism behind echolocation and hence sonar. My name is Walter Unglaub, and this is Echolocation in Physics.